next time we're in some place together, we should do some dialogue.
Absolutely. And when they visited,
Yes, and you
it's something unique. I tend to be loud. It's very rare that people, but if anybody else will ask. Oh, it's not quite very near. My volume will go up with the feedback. Vai. So maybe you need something to say. I don't know if it's free. I had a Chandra Sekha that I do very well. Chandra Sekha and Joseph practically the first the crop, mainly the way
Cosa posso chiedervi?
Fingers and laughs. Let me leave it there. My volume always goes up and mainly the possibility. It's going to be a beautiful day. It's 2 more weeks, but it's nice to be able to. The thing about travel, I like travel, and I travel with
perché proprio ci stava lasciando in affidamento a me e io lo sì, cos'è?
Queste sono le dimensioni quello ancora
e ha cercato di introdurre questo concetto nella mente e ha scritto un libro
from Carnegie Mellon, the title is Richer than Reduction, scientific discovery by Intertheoretic constraints. So, thank you. I was going to try and do this without the microphone, but please let me know if I'm not loud enough. It's very rare that people tell me I'm not loud enough, so I thought... Well, is that going to be okay, Emiliano? I haven't thought about that. Okay. I'm loud a little bit for the video. Yeah, perfect. Wonderful. So thank you very much to the organizers for inviting me. This has really been a fun couple of days, and it's really, I've learned a tremendous amount, and it's been a real pleasure to be here. So I hope you all don't mind. I used this as an opportunity to, in the second half of the talk, try out some new ideas that I worked out, but this is their first public presentation, so please bear with me if it doesn't always go smoothly. I should also mention that I have, as you can see from up there, an appointment also in psychology, though philosophy is my primary home. And I'm going to be talking about psychological examples today, but I want to make sure to emphasize I'm not doing psychology. I think that the things that I talk about are actually the kinds of things that many scientists, including myself when I put on my scientist hat, are thinking about in these kinds of cases, but I don't have any data on that. I mean, I've got anecdote, namely my own experiences and talking to people. So, although the examples will all be drawn from psychology, I'm not doing psychology, at least right now, but would love to in the future. So, I think one of the things that has really been very, very helpful for me over the last day and a half, 2 days, has been to see the sort of the diversity of strategies and ideas that people have focused on and have brought out about scientific discoveries. So, there's one that hasn't been talked about actually very much, but is the discovery strategy of, we'll just collect more and hope. It's the wishful thinking strategy. Collect more data and hope that you have a good idea once you see the data come in. There's been a lot of discussion about reasoning by analogy, or various other kinds of mental schemata. Abductive and or inductive strategies. I deliberately haven't used the word heuristic up here because I think I come from a background in psychology where heuristic has some very specific connotations that I think would not be endorsed by a lot of the people here about, these are somehow suboptimal or not the right thing to be doing or lazy shortcuts, which I don't think is the way that anybody here has been thinking about it. What I want to talk about is one that actually there's been less discussion of, so I'm thankful of that because it means nobody has stolen the ideas yet, and that is trying to just do some elements of discovery by looking at how our theories compare to one another. Okay, so this is really what I focus on, is this fourth one here. And the reason for this is because there's actually a very especially in the biological and psychological sciences, I think that there's this idea of reduction. So there's the sort of metaphysical doctrines of reduction. Can you take, say, mental states and reduce them to neural states? Or can you take population-level phenomena in evolutionary biology having to do with natural selection and reduce it down to causal stories involving each individual critter, each individual organism? And so, there's this, at least in the training I received, a quite classic paper by Bill Wimsatt, Reductionist Research Strategies, which made the move away from reductionism simply as a metaphysical doctrine to suggest that instead maybe reductionism could serve as a kind of discovery strategy, that it could be a guide to how we as scientists ought to engage in a certain amount of the research that we do. And I think we've actually seen elements of this in some of the talks so far at the workshop, where the idea becomes, here's this theory at some level, and what I want to investigate is, can I come up with a reduction of it? I think there's a flavor of that to some, for example, some of the things that Lindley was talking about, where it's trying to figure out the mechanisms. So we want to take some high-level, very abstract, functional characterization of some phenomenon, and maybe it's not quite a reduction, but it's trying to find a lower-level account of what generates that particular phenomenon. And in fact, in psychology, it's really kind of ubiquitous. These were just a couple of things that I pulled off recently. The theory in psychology papers from 2006, I think, and then this was a 2014 or 13 book, where it says, you know, philosophical essays of psychology, neuroscience, and reduction. Almost every essay in there is about why it's a really good strategy to look for reductions. John Bickel in psychology and neuroscience is rather famous or infamous for hammering on the idea that if you really want to make progress in psychology, what you ought to do is search for reductions. That's the discovery strategy that one ought to use. And so you can think about this. It's actually, I think people tend to focus on a sort of first kind of way that reductionism can serve as a discovery strategy, namely, you've got some high-level theory, and you try and think about mechanisms, and those are deliberately with, in American, I have to be careful, I don't know if this is true in British, but in American, we call those scare quotes. That you put quotes around things to say, it's a little bit scary, I'm not sure, you know, don't take it too seriously. So when I write mechanism, I don't necessarily mean this sort of thick notion of mechanism that Lindley was using. It's a more thin notion, perhaps, here. The idea being that you've got some high-level theory, and then what you do is you try to find sort of the pieces that generate or explain or constitute the high-level theory. But I think interestingly, and this happens, there's also a second strategy that's closely related to reductionism, which is actually to go in the other direction. And one finds this more and more frequently in modern cognitive neuroscience, where you start with a low-level theory, and then you sort of ask, are there modules that we can package these pieces together into? Can we take a whole bunch of small steps of things happening in visual cortex and group them together into a single functional module? Okay? So in fact, you can think about, instead of going from top down, you can actually go from the bottom up, because as you know, as has been noted many times, if you want things like explanation and understanding, you need to think very carefully about the level at which you're providing a theory. You don't necessarily want the lowest level possible theory in order to explain or understand some phenomenon. Now, the notion here of high level, I want to make sure to emphasize, is, and it's too bad Tom isn't here because this is you know, his classic 73 paper, Two Concepts of Intertheoretic Reduction, in which he points out there's at least two different notions of reduction. Reduction as a kind of limiting case, or the other direction, right? So we can reduce Newtonian mechanics to general relativity, Newtonian gravitation to general relativity as a limiting case. And then there's reduction in the notion of sort of levels of description. Okay? And we might also wonder whether there's reduction in levels of explanation, but that's a whole other side issue. And I'm going to criticize that. I'm going to say that this is not always the right way to go. So, but I want to make sure to say, I think this can be incredibly powerful. Okay, so reductionism as a kind of strategy for discovery, as a strategy for trying to guide inquiry, for setting goals. I think, I'm going to get it wrong, Lindley, product yields process?
The nature of the product guides the process.
Nature of the product guides the process. And I think that that's actually true. I mean, I think a lot of times when people are trying to engage in scientific discovery, they have an idea of, in some sense, what they're trying to discover. Mathematicians don't just do a sort of combinatoric explosion in proof search. You've got an idea of what you think the theorem probably is, or you think you know what it is up to negation. You don't know if it's true, if it's the claim or the negation of the claim that's true, but you've got an idea of what you're aiming for. And if you can actually find a reduction, you can get the lower level theory can refine the higher level theory. The higher level theory can actually give you much better explanations than the lower level theory can. You now can get an integrated multi-level theory, so people who worry about issues like multi-level causation, can you have causation at multiple levels? Well, if you can get a reduction, then you can understand the notion in which there's causation operating at multiple levels. You can get predictions that are much more sophisticated and complex. You actually also can get new connections. Suddenly we have linkages between neuroscience and psychology, between psychology and economics, between population and organismic biology, right? So they're incredibly powerful when they work. The problem, but you knew that this was coming, one challenge is that they're actually incredibly limited in their scope. So the notion of reduction presupposes that we actually have pairs of theories that exist at different levels. Okay, so you can't talk about a reduction between, say, a correlational claim at a higher level. Right? That's not the kind of rich thing. I mean, when you look at the theories we have of what a reduction is, there's 50 years of philosophical work on this. There's incredibly rich, sophisticated theory accounts of reduction, all of which presuppose that you've got theories on either side of the reduction relation. It truly is an intertheoretic relation. You in fact need to have them on different levels. You don't reduce things that are at the same level of abstraction and description. That sort of doesn't make sense. Things at the same level of abstraction or description are typically viewed as competitors, not things that you reduce to. The levels can't be too far apart. Right? We don't think we're ever going to have a reduction of economics to quantum mechanics. That's just, well, I don't know whose dream that might be. It's not mine, and it's clearly not going to happen. Right? And so we seem to have this real problem. I mean, yes, and I'll just note, real reductions, even if you've got two theories, are incredibly hard to do. One of the first early things that I did in graduate school was establish a reduction between a set of human causal learning theories at a couple of different levels. These were at very close levels. They were mathematically well-specified theories, and it still took 6 months of work, of just pure theory work, to establish the reduction. Right? They're really, really hard to do. Right? So they're powerful, they're wonderful, but they can take decades in some cases to try to establish. Moreover, they actually don't work as well as the classic canonical cases would have you think. It is frequently the case that at least some of the boundaries that we think are important at the higher level theory don't necessarily manifest in the lower level theory. Now, if you're somebody like Paul Churchland, you think this is reason to reject the high level theory or revise the high level theory in the case of cognition. But in fact, oftentimes that doesn't hold. We don't have a natural revision, or the revision is not actually as predictively powerful, ironically enough. It is not always the case that the theory that would strictly reduce is as useful or as good for understanding an explanation. Moreover, it is also the case that sometimes things down at the lower level don't actually modularize in any interesting way. Think here about Freud's vision of the way that the brain worked, which was basically just an enormous neural network. This is Freud in the first part of the 20th century. So essentially an enormous, undifferentiated neural network in large parts of the brain. Well, he didn't deny that there were meaningful high-level accounts of human behavior. That's a lot of what he was trying to do, is talk about desires and beliefs. And whether you buy Freudian psychology is not the point. The point is, his whole picture had a lower-level theory that simply was not going to modularize. The higher-level behavior was in some sense patterns and regularities that, and I hesitate to use this word, but emerged from the patterned, structured patterned behavior of the individual. It did not necessarily show up at the level of parts of the brain. Well, so you might think this is a problem. We're losing this discovery strategy. We had this wonderful discovery strategy available to us. Gee, this is great, but we're losing it because it won't work. Well, I want to suggest that the problem is actually that we put too much under reduction. We asked too much of just one intertheoretic relation, when in fact there are many intertheoretic relations. Theories, and I'm going to put them in those scare quotes here, are related in much more interesting and complex ways. And scientific discovery should try to leverage all of these relations, not simply the special case that is reduction. So is there anything that we can do to try to bind these relations together? Well, I want to suggest, and this is some work that goes back a couple of years, Blatant Self-Promotion, my book from a couple of years ago. One of the chapters is a lot about that. Unifying the mind, in case you're curious. I set out this idea, but then I didn't actually do very much with it in the book. It was sort of a proof of concept, and so what I'm trying out here is actually using this idea to do some work. So the idea is that we should instead think about simply intertheoretic constraints. That constraint is the relevant notion here, not reduction, not autonomy, not limiting case. Constraint is the generalized notion. So the idea is that one, broadly speaking, theory, so when I use S and T here, I don't mean theory in the sense that's required for reduction. Okay? That S constrains T relative to a theoretical virtue. So what's a theoretical virtue? Well, these are things like explanation or explanatory power, accuracy, perhaps truth, if you like that as a notion, simplicity, fit to data. Right? All of these are different kinds of theoretical virtues. And constraints are relative to theoretical virtues. That's something that's going to come out a couple of times. And the point here is that one theory might constrain the truth of another, or one claim might constrain the truth of another, but not actually constrain explanation. It doesn't change whether the other can give explanations or the kind of explanations that it gives. One account, if I give a sort of purely instrumental theory, then that might constrain the predictive success of other theories, namely they need to match it if it is actually successful. But that doesn't thereby constrain the objects that are postulated, because the whole point of an instrumental theory is I'm postulating an account of the data, an account of the phenomena, without thereby postulating any or being committed to anything about how the world is. It's exactly an anti-realist picture. So we need to keep these separate. Now, one nice thing is that if you think about what, at least in the biological and cognitive sciences, there really are two standard relations, intertheoretic relations that anyone ever talks about, namely reduction and autonomy. Autonomy is the one that people like Fodor want to hold out for the special sciences. And the nice thing is that we can express both of these as particular sets of constraints. So reduction is simply the constraint. It's a sort of maximal truth constraint. If S reduces to T, then if T is true, S must be true. Right? That's just what it means to give the reduction. Or if T is predictively accurate, then S must be predictively accurate to the extent that it isn't averaging over or aggregating out in predictively important differences at the T level. Right? But whether it's explanation constraining now depends on the distance. Okay? So imagine in this dream, nightmare, that we did have a reduction of economics to quantum mechanics. That would mean that if quantum mechanics is false, then our standard economic theory must also be false. Right? That's just what that, If economics reduces to quantum mechanics, then if quantum mechanics is true, then economics is true. That's the one I meant. Right? But as we just had said, that doesn't thereby impose an explanation constraint. Whether quantum mechanics explains some phenomena does not in any way constrain whether economics can explain some phenomena, and vice versa. Okay? Autonomy is interesting because this is, the, for example, the argument that psychology is autonomous from neuroscience, which is to say that progress in psychology is entirely independent of progress in neuroscience, that psychologists need not pay any attention to neuroscience. To the extent that you think that psychology is purely functionally characterized, then you might be, or you think that, if you really buy the arguments of multiple realizability and so forth, you're going to believe in autonomy. And autonomy is nice because it's actually the explicit rejection of constraint. Okay? It's not just we don't know the constraints, it's explicitly denying that constraints exist. Right? And there's actually a lot of other nice benefits if we start talking about constraints, because we can talk about constraints within levels of or between levels of explanation. We talk about constraints between levels of abstraction, constraints between levels of description. You can have these different kinds of constraints. You have these different kinds of levels, and you have different constraints within each of these frameworks. Right? So you get a nice explanation for things like, if people know David Marr's 3 levels, which are very popular in cognitive science and neuroscience these days, and are actually a kind of confused mess, you can explain why they're a confused mess using these sorts of ideas. So just a few key properties that I want to make sure to emphasize. I do want to emphasize constraints here are non-subjective. So when I was talking about I'm not doing psychology, this is part of the point. Whether a constraint exists is a feature of the theories themselves, or the theoretical claims. It is not a feature of the scientists themselves. Okay, so whether a constraint exists is independent of whether the scientists know a constraint exists. That one thing that you can do in science is you can discover that there are constraints that you did not previously know about. Right? So it's not an invention that occurs, it's a discovery that occurs. There's no particular requirement that these be restricted to fully specified theories in the sense of reduction and so forth. A somewhat side is not going to come up very much here, but issue is that it turns out that when you try to explicate the notion of constraint, it's relative to the alternatives. So whether one theoretical claim constrains another depends on what you take to be on what are the space of alternative claims on both sides of the relation. Right? Now, again, I want to emphasize this is not. It's not. You may have noticed I caught myself. It's not what you take to be the alternatives. What it's relative to is what actually are the alternatives. You have to specify, in fact, a set constraining a set is what it comes back to. But what this means is that there's now room for history. Because whether a theory is known to constrain another theory is going to depend on what were the historically contingent sets of alternatives considered at a time. So if you don't consider a certain theory or a theoretical claim as a real alternative, then there may actually be different constraint relations that hold because you're considering different sets. Right? So there is a notion of subjectivity, a notion of a certain kind of perspective dependence here, a kind of history dependence, what is taken by the scientific community to be the live alternatives will shape which constraints are relevant at that moment in time. Okay? It doesn't create or remove constraints, it just says these are the constraints that matter to this community. Okay, so there is a kind of subjectivity or perspectival nature to it, but it isn't in the constraints themselves. It's in what we take to be the relevant alternatives. So let me just try and give a quick example of how this could get cashed out in a bit more precise way. So what's the notion of a truth constraint? Well, the idea of a truth constraint is that the truth of S truth constrains T just when the truth of S matters, in some sense, to the truth of T. The obvious idea is, okay, that means that the probability of T changes if given S. So if S were true, that is to say, probability given S, then the probability of T would change. That's a very natural idea. It doesn't work. It doesn't work because the P there doesn't actually, you can't cash that out in a coherent way. If these are subjective probabilities, then we aren't getting objective constraints. If they're objective probabilities, then you have to explain what it would mean to say that some theory has an objective probability of being true. We normally think of our theories or our claims about the world, if we're being at least moderately realist, as either being true or false. We're trying to discover things that are either true or false. So objective probabilities don't actually make much sense when you're talking about probabilities of theories. Right? This is part of the reason that the Bayesian accounts of science are always emphasize that they're doing subjective probabilities. Now, these might be objectively subjective probabilities, right? They might be the ones that if you started from a flat prior, you would have reached. But they're still about what the scientist, or some rational reconstruction of the scientist, is doing. It's also the worry that many times these probabilities are not going to be well defined, the conditional probabilities in particular. Oftentimes, it's just not going to be... So if the set of alternatives includes the possibility of something else that we haven't thought about yet, then the conditional probabilities will typically not be well defined. Okay? So there's lots of problems with trying to use probability here, even though it's a really natural idea that I confess I spent multiple weeks trying to get to work before I realized that it was just the wrong tool. So what might we do instead? Well, we could understand truth constraint as now a change in belief, okay? But not a change in belief in actual scientists, but a change in belief from a fully knowledgeable agent, right? So if my beliefs in S change, for whatever reason, okay, then if I would change my belief in T, if I were fully knowledgeable and rational, then there's a truth constraint. Okay. Now this is deliberately formulated in a kind of conditional manner, right? The constraint is, look, if you get some change in belief in S for whatever reason, then you ought to change your belief in T, right? It has a normative force to it. So the idea here is that the triggering belief change, wow, you really can't read that stuff in there. I apologize for that. The triggering belief change need not be rational, right? It's a conditional. There is a requirement of full knowledgeability here, because that means that's what's needed to ground the objectivity, right? And it also means that you now have an explanation for why the discovery of constraints can themselves be part of science. We are becoming more knowledgeable. We are becoming some of those fully knowledgeable agents that understand the relationships between the theoretical claims. And the connection here to rational change of belief, you might worry. You might say, well, wait a second, what do you mean by rational change in belief? Aren't I right back into the problem? Well, there's actually many stories out there. This actually says, and I think this is a feature, not a bug, of the account, that whether you think some theoretical claim truth constrains another one depends on what you think it means to rationally change your belief. If you buy into AGM-style belief change, or Bayesian updating, or Isaac Levi-style looking at sets of probability distributions, whichever one of these you want, or any number of other options that are available, that is going to shape what constraints exist. Right? And that's, I think, as it should be. Because if the constraint is going to have a normative force, then there's got to be some normative theory that backs it. And it seems to me we don't actually know what the right normative theory of rational belief change is yet, so I would prefer to remain agnostic on that front and have an account that can be flexible depending on what we come to believe as a community. So there's lots and lots of open questions about these things, these truth constraints. Generally, to what extent can we translate, say, the idea of converging evidence in a science as sort of mutual support, which is to say mutually truth constraining, right? If this theory is true, then that one's probably true, and vice versa, right? And I think that we do this in science. We think that there are often sort of clusters of theoretical claims that fit nicely together, where the idea is that if you get support for any one, you're also getting support for the whole cluster. Are there, certain theories we ought to use that are better than others? But the key point that I really want to emphasize here is just that constraint is the relevant idea. So we generalize away from reduction to this notion of constraint. And in particular, I've been focused here on truth constraint, but I've worked it out also for accuracy constraint and explanation constraint. I've not yet been able to work out just because I haven't yet figured out what an explanation is, so it's a little bit difficult to figure out. I know, how could I not know what an explanation is? I know. I'm a slacker, I'll get to work on that. What I want to emphasize though is that these actually are these constraints can provide a guide to scientific discovery. I mean, I think it's sort of, if I've got some set of S's, or if I've got some domain where I'm trying to discover T, and I've got a set of S's that I think are plausibly true, or plausibly explanatory, or plausibly accurate, this will then constrain, give me information about the space of possibilities for D, the theories that might solve the problem D that confronts me. Okay? It's a kind of, you can think about this as, there was some discussion about various inductive and abductive strategies. You can think about this as giving a kind of soft control mechanism that says, here's the kind of target you probably want to look for. Because it's the one that our current scientific knowledge places constraints that makes it likely that this is the right one to look for. Not likely in any strong probability sense, but this is where you might want to aim your search. Okay? Now, of course, the constraint types are going to depend on what I want to do with the problem. If I want an explanation versus predictive accuracy versus some notion of truth. You might have to discover what the relevant other theories or theoretical claims are. There might be things that you think don't matter, but then you discover that they do. Right? So discovery can be the discovery of constraints that then inform future discovery. You might not have thought that 2R, to use Monica's example from yesterday evening, would matter for this semicircle, but then you discover that that is an important constraint that's relevant. Right? I don't want to suggest that this is going to yield unique answers. I think it very rarely will. So it's not that this is some algorithmic procedure that you just plug in. Again, in American, there's the phrase plug and chug, right? You just put this in, you just turn the crank, and out pops the answer. That's not how science works. That's not how discovery works. But these are guides. They're ways of improving discovery, I want to suggest. Right? I also want to emphasize, undoubtedly, in practice, these are going to be typically domain-specific. You're going to have to know a lot about the domain. So you can't just walk in as an outside philosopher of science and say, oh, let me give you the domain general system that will solve all your problems. But I think nonetheless that it can be very helpful. And so what I wanted to try to do here in the last 15 minutes is to quickly run through 3 case studies and then draw a few morals from them. So I gave you some formal details about what a truth constraint looks like. I thought it would utterly bore everybody on a Saturday morning after a wonderful dinner last night to go through those. So I'm going to do things in a very qualitative way, but I can provide you the details if you actually are really curious about how to cash these things out in the framework that I just had given. So the first is, you might wonder how our causal knowledge is structured. So again, these are all drawn from cognitive science because that's what I know the best, right? In fact, all 3 of these are ones that I've worked on personally, and so these are my sometimes people talk about anecdata. It's not just an anecdote, that would be one. Anecdata is you start to get several anecdotes and you start to think maybe this counts as data. So one question you might ask is, how is our causal knowledge structured? We humans navigate the world, we control our world using causal knowledge. And you might wonder, can we say anything about what in our minds these representations of causal structure, what they look like or what form they have? Well, here's a couple of constraints that might guide our inquiry. Now, of course, part of the way that this inquiry is going to go is we're going to do experiments on this. But here's a couple of constraints. One is that it turns out that if you look at people's decision making, people generally understand their own actions as having a kind of uncaused, relative to the system they're acting in, component. Whether you want to call this free will, spontaneity, there's lots of names that get given to it. But this emerges, this idea of the sort of self as an exogenous actor, someone who's able to act on the world without necessarily being inside the causal structure of the part of the world I'm acting on. Right? That emerges somewhere around 6 to 9 months of age. Okay? It's that early that this self-conception of ourselves as a kind of exogenous actor shows up. Now, part of the reason that we need causal knowledge rather than just correlations is precisely because that matters. The cause-effect asymmetry matters when you're an outside actor. Right? If I want to turn the light, if I turn the lights off, take a step. If I flip the switch, that changes whether the lights are on. If I act on that part of the world, it has the effects it has. If I change whether the lights are on by smashing them with a hammer, I don't thereby change the state of the lights. Switch. Right? Or, if you have the correlational knowledge that hair color is correlated with job title in academia, right? But it would not be an effective strategy to dye one's hair to get a promotion, right? Certainly don't recommend it to the junior faculty, right? Don't dyeing your hair gray is not a good way to get promoted. We know that causal knowledge is deeply connected to our ability to act effectively in the world. But we've got this constraint, which is that we think of our actions as being uncaused. So I'll get to the implications of that, right? Moreover, our decisions are appropriately responsive to information in the world. So we don't just sort of act blindly. Sometimes people want to say that it's important that there be an element of randomness in our actions, but I suppose I come down on the side of Hume, that random action is the province of, as he said, idiots and children. Now, I don't think either of those is right, but I think it's true. People who act randomly, we tend to think of as a little bit off. We don't think of them as having free will. We think of them as not being. Part of free will is appropriately responding exactly to our world, right? So we're not, which is not to say that we are determined by the world. It's just to say that we should be responsive to. So again, however our causal knowledge is structured, it had better also be able to incorporate this kind of observational information. Now notice, reduction's not going to help us at all. These constraints, let me go back. These constraints, S1 and S2, they aren't at different levels from the representation of causal knowledge. They're things that use causal knowledge. So they're not really at different levels, they're just constraints, right? They also aren't really theories. I mean, I've given you some general qualitative features. I haven't given you a theory in the sense of the kinds of syntactic or semantic or other notions of theories that were so nicely laid out yesterday afternoon, right? But nonetheless, there are constraints here, right? So for example, people had better be able, using S2, to update their beliefs, to learn using their causal knowledge, given observations. Well, this actually rules out a whole class of psychological theories that says our causal knowledge is represented just as sort of brute action selection pairings. Essentially, this would be if we were like rats and only learned through instrumental conditioning, only acquired causal knowledge through instrumental conditioning, then you would have a representation like that. But we don't. We update in ways that rats don't. Right? So if a rat learns to press a lever in order to get a food pellet, if you trigger the lever to go, the rat does not differentially do nose pokes to look for food. Right? Pavlov's dogs never learned to ring the bell to get the food. Right? We also have to be able to predict the outcomes of our own actions. Right? This is the S1. And this rules out the kind of standard view that, all we do is construct associative models. We're just associating things in our environment. Because associative models don't yield the asymmetry of intervention that's needed. So all of these together make it more plausible that, in fact, the way that our causal knowledge is structured is with something like, say, a causal graphical model. That's so you've got this space of models, and you might have a priori thought a causal graphical model, that's way too complicated. There's no way we have a rich representation like that. If you know what Bayesian networks are, that's a kind of causal graphical model. Causal Bayesian nets are a kind of causal graphical model. But what these constraints do is they change where we think we ought to look, essentially. It changes and leads us to say, maybe we ought to look over it in there. Maybe we should take seriously this possibility that 20 years before was not taken seriously. Now, a causal graphical model, if just as a piece of background, because it's going to come up again, essentially there's two pieces to it. There's a graph that gives some notion of qualitative direct causation. Exams just recently finished at Carnegie Mellon, so this example is sort of very present in my mind. All the students focus on that upper causal pathway. Studying improves their knowledge, which improves their test score. They neglect the lower causal pathway. Studying takes away from their sleep, and sleep also would improve their test score, right? So they never think about the possibility that, in fact, there's a point at which studying no longer will help your test score. Sleep would help more. And then, to make this fully rich, if you're in machine learning, you pair this with probability distribution. In humans, it's actually unlikely that we have full joint probability distributions. We have something more like a discrete distribution, a discrete interval distribution rather than a true full probabilities. But that's okay. And these get linked together in a whole technical way that I could give you a whole other set of talks about if you wanted. And what's striking is this is actually roughly what happened about 20 years ago in the work that people were doing on the structure of human causal knowledge. Is this idea came out that, maybe we should look at causal graphical models in part because of the two constraints that I gave. And nowadays, these are the way that everybody represents causal knowledge in the cognitive science community. Human causal knowledge is, there's not really much debate anymore that a large part of human causal knowledge, our representations of it, are structured approximately like this. Okay? Now, are they structured exactly in this way? Probably not. Is it exactly the full thing that we use in machine learning? Probably not. Do people have other things that influence their causal reasoning? Undoubtedly. Is all causal knowledge represented this way? Probably not, right? There's all the caveats. But there is a change over the last 20 years. There was no mention of causal graphical models 20 years ago. Now every paper at least engages with it because it's understood that this is a very good picture of what's going on for a large part of our causal representations. Right? And that's partially because we decided to look in a new place because of these constraints. So I'll go a bit more quickly here. It's also known that at least some of our concepts are defined in part by their causal structure. So the part of your conceptual knowledge about, say, cats is, not Kant, but cats is about the shared causal structure that's within all cats. That's how you know that, if you were to shave a cat, it still is a cat. But a 3-year-old does not know that. Right? You come to have this kind of understanding. This gets elaborated in psychology as a notion of the theory, it sometimes is called. Here's a constraint we've got. Our knowledge of causal structure is probably represented sort of like a graphical model, causal graphical model. And we also know people sort of spontaneously generate concepts. So that suggests, notice again, no role for reduction. Right? S1, the fact that we represent causal systems as graphical models, if that's correct, that's not, you wouldn't reduce that to theories. It's just sort of a side, it's another theory at a very similar kind of level, right? There's not a role for reduction here. There is a role for constraint, right? It raises the possibility that, hey, maybe those concepts, actually the representation of them is one of these causal graphical models, right? And that suggests a whole line of new experiments, which largely bear out this idea, right, that it was the right place to look. And it actually generates now a whole new set of experiments because we've, as the first word in the title suggests there, we've unified a set of representations. We've now unified representations of causal structure in the world with aspects of our conceptual framework. We've now been able to understand these as parts of, or the same part of, a much larger whole. So we get a whole new set of experiments that actually turn out to continue to validate, or at least not disconfirm, this idea that there's this shared internal structure. A third very quick example. Do our goals influence what we learn from the world? Right? Well, that might seem kind of odd, right? You might have the picture as most, well, I'll get to this, actually, I'll do that on the next slide. So here's a constraint. Learning, we think, depends partly on what you attend to, what you look at in the world. That if you don't pay attention to something, you don't learn as much about it. That's a pretty standard finding in the perceptual learning literature, except for very specific kinds of implicit learning behaviors. There's reason to think that people differentially allocate their attention depending on what they want to learn, what they want to accomplish. There's evidence of that. So we seem to get a constraint, right? Maybe our goals, what we think we're going to need to do, shapes what we learn about the world. Right? Now I want to make sure to emphasize, this actually is something that very few cognitive scientists think is very plausible. Right? This is work that we've been doing in the last 2 years, so I'm very familiar with what most cognitive scientists think of this idea. Most of them think of learning as constructing a mirror. That learning is about basically having representations that mirror the world. And then reasoning and inference and decision making, that's where the goals come in. Right? Learning's about sort of having an approximate mirror of the world, and then the goals, those show up when you want to do things with whatever you've learned. And the argument here is to say, well, no, wait a second, maybe the very thing that you learn is shaped in deep ways by what you think you're going to need to do. Not just in terms of your mirror is partial, but in fact your mirror might be distorted. That it might be that you will rationally learn false things because the false things are more effective at helping you achieve your goals. Right? This is a very strange idea to many cognitive scientists right now. Given the widespread views of, the widespread influence of neural net models and Bayesian models and other kinds of rationalist models in psychology, it's kind of a weird idea. But in fact, it turns out experimentally we've got now rapidly growing evidence that, in fact, exactly those constraints do lead to goal influences, do help us understand that there are goal influences because it does seem to be mediated by attention. Right? And I could go on and show you examples of that, give you some fun experiments, but I'm not going to do that. Instead, I'm going to quickly try to close up, given the time. So I want to make sure to just emphasize, you might be sitting here going, wow, those were really boring case studies. They were not nearly as cool as Donald's case study of thalidomide. It really, they just weren't. They were really kind of boring. Because they're the kind of thing that if you've ever done science, you go, yeah, that's what you do with science. You think, well, what else do we know? How does this impact? How does this help us figure out where to look? They should be banal. I chose these examples because I know all three of them. I've contributed to all three of them. They just happened, they were convenient to me. I can tell you the details. And this is the part I didn't show you, but I worked out, I could write down the constraints in fairly clear detail. I could actually show what the relationships are, not just at this sort of intuitive, qualitative way I did here in the talk. I can make them more precise in important ways. Right? So it's unexceptional that we use other pieces of scientific knowledge. But that's actually, I think, a good thing about this framework of constraints, is that it applies and can make sense of completely ordinary cases of scientific discovery. I think speaks to its credit. I think sometimes, I'll get on a bit of a soapbox here, I think sometimes in philosophy of science we focus too much on the exceptional cases, on the revolutions, on the how did this ever work? And we forget that a lot of science really is normal science, and maybe we should try to have accounts that explain normal science as well. The kind of ordinary, we don't know the answer, but we've got an idea of where to look, and then we go and succeed in finding something. So the intertheoretic relations are really many and diverse. And this notion of constraint, I think, can serve to largely generalize away from reduction and autonomy in a way that can start to help us see how different theoretic claims, theory, right, because again we're moving away from having to have full-blown theories, can actually help. So just to summarize, I think that intertheoretic relations really are a valuable guide to discovery and theory construction, and it's important that we try to understand what these relations are, right? But reduction is only one. We shouldn't focus only on it, and instead we should look more broadly at constraints as a way of understanding how our scientific beliefs, ideas, knowledge constrain one another to help guide where we look in the future. So, thanks.
Yeah, so thanks for a great talk. Yeah, this notion of constraints is really interesting, and I was wondering about you mentioned about theories of belief change, and so I guess, in looking at these cases, you probably worked out these details, but just as at an intuitive level, you might be tempted to think that depending on what theory of belief revision you adopted, that might change the way you looked at these constraints.
Yeah.
So the notion of constraint then becomes not something that's sort of, it becomes less objective maybe in the sense that, because your first your desire to leave out a probabilistic account of theory, you know, P of T is, so was to avoid any kind of subjective or, you know,
Right.
sort of account of that. So then if you adopt this, depending on what theory of belief revision you adopt, isn't that going to feed back into the
Yeah.
way you look at the constraints?
Yeah, great question. So let me answer in two ways. The first is to say these cases turn out to all be pretty straightforward. Doesn't matter which theory of belief change you have in mind. And any of the ones that people have actually defended as rational, as having a normative force to them, all give the same answers here. Because we're not jumping all the way to certainty. And these, you know, there are places where AGM comes apart from Bayes, comes apart from, you know, Hannes Leitgeb's recent work, but not in ways, but where they come apart are not these kinds of cases. So these case studies were okay. But so that's the first part. The second part of the answer, though, is I actually, I think what it introduces is a norm relativity, is what I would say. But I actually am okay with that, because it seems to me that if the right theory of belief change says that you ought not change your belief in response to some other change in your belief network, then I go, okay, it seems to me there just isn't a constraint there. Now, you might very rightly object that what I've done is I've now pushed it off and said, okay, you people in rational belief, rational choice, you need to figure things out and tell us which one it is, so that I'm not left as a researcher saying, well, they don't know yet, so I guess I have to pick one, right? I completely agree. I haven't yet gone into that realm, and I'm a little leery of going down that, having some colleagues who work in it. I think, I'm not sure that we're going to get an answer anytime soon. So I'm very sensitive to that worry. My hope is actually that most of the time it doesn't matter, that it'll be like these 3 case studies. That was part of the reason I decided I should really do some case studies, is to see where, you know, what are the pieces that really were doing most of the work. And it doesn't seem to be which normative theory you use that's doing the work, at least in these cases. So one thing I've thought about trying, but I haven't looked at yet, is can I actually figure out what would be a case where they would come apart, and then look to see if I can find something scientifically that looks like that. I think that would be really interesting to do.
Yeah.
So.
Yeah, thanks, that's a great topic.
So Emiliano.
No, forse siamo quattro di me. Okay. So, thank you, David, for your very nice talk, and was also entertaining. And my question is about, I'm trying to reversing the focus. What about violation of constraints? What do you think about the violation of constraints as a way of building theories? If you have any thought about this, instead of putting constraints? I know it's...
Yeah, so... Right, so that's a really good question. I'm going to try to answer it. Here are some quick thoughts, because the short answer is no, I haven't thought carefully about it. My first reaction, but this is making me actually think. My first reaction is to say when you get violations, in the sense of these things are constraining in important ways, but yet the data just say that's wrong, right? That oftentimes what we do, it seems to me, is we now change. So one nice feature about this account is that, at least for theory chain, for the truth constraint, and also for accuracy constraint, almost always it's symmetric. If S constrains T, then T constrains S, right? So one thing I think that we might sometimes do when there's a sort of violation is that we then reverse the order. We say, okay, those things that we thought we knew, maybe we should go back and revisit them, because what we're seeing doesn't make sense with them. So maybe we need to open those back up to inquiry in a way that, usually in science you take a few things for granted in the context of inquiry, and then you come back and revisit them later. Maybe that's a trigger for people to revisit. I suspect it's also that it may also be a trigger for the kinds of revolutions that maybe,
Yeah.
we need to talk
Right.
about, because it could lead to exactly, I mean, I hadn't even thought about some of the work I've done on things associated with perspectives. I'm not going to say perspective, well,
She's gone.
Michaela's left. I wasn't going to say perspectival realism, but things on the important about the role of certain aspects of perspective that are different than what Michaela's worked on with regards to science. But I think that actually this, now that I think about that, could be another sort of trigger. When you get, if not violation, when you get tension, right?
Okay.
The constraints don't seem to be fitting correctly, or the constraints aren't leading in the right, in a coherent direction. That this might prompt us to sort of say, maybe I need to rethink the whole framework I'm using here. So yeah, I think that's a great question, and I thought about the happy cases, not the sad ones.
Thank you.
Yes, well, you're obviously looking for more glamorous case studies, but I think that they're quite easy to find, actually. Because I think your approach, what I was thinking is, I think it does work actually rather well for the analysis of revolutions in science. You were saying it's only normal.
Uh-oh. All right, this is wonderful.
No, I'll explain why. You see, what typically happens in a scientific revolution is that you have the change of paradigm involves changing a lot of theories. Now, one of them gets changed first, and then that constrains how you build up the remaining bits of the paradigm. So, for example, take the Copernican revolution. As soon as you say, well, the sun is at the center and the earth goes around the sun and so on, Aristotelian mechanics just won't work, because it all depends on the earth being at the center of the universe and so on. So, you've got to build up a new mechanics, and you've got a constraint there. If you're a Copernican, like Galileo, Descartes, Newton, you've got to somehow think of a mechanics which will agree with the Copernican constraint. So I think that's what they were doing. And the second example would be the Einsteinian revolution. You see, Einstein begins by producing special relativity. Now, if you accept special relativity as a new mechanics, it's impossible that Newton's theory of gravity is going to work. I mean, it just is not compatible. So you really do have to think of a new theory of gravity, and you've got a constraint there. It must be compatible with. So there you are. You see, you can have lots of glamorous examples.
No, this is great. So because I think the reason I've been trying to stay away from the revolutionary things, I will say, is because it often seems to me that in those cases I was thinking it not in terms of the dynamics of within the revolution as it's happening. I was thinking about it from, to use the Kuhnian language, paradigm 1 to paradigm 2. And in both cases, each paradigm, there's an enormous amount of mutual support within that. But I was having a great deal of difficulty thinking about how the two paradigms might constrain one another in some sense. This seemed very difficult. But I love this idea of thinking about, no, it's where does the paradigm come from? Because paradigms themselves emerge dynamically over time. And this reveals my relative ignorance of the history of science. I do not have I don't have the H in the HPS background. I was not a Pitt student. But that's really wonderful to think about. I may need to walk across the way to Pitt and talk to some of my colleagues over
it's
there
just the
about these
fact
cases.
that the new paradigm doesn't appear completely.
Immediately, yeah, no, that's
Usually
right.
one bit appears, and then that constrains how you can.
Yeah,
If you do buy into the new approach, that constrains how you're going to build up the rest.
I was going to say, in fact, I suspect that in a lot of these cases there may well be evidence of people saying, well, if we buy this, how does that shape the possibilities that are available to us for what the next steps are? That would really be fascinating to talk to some of the historians over at Pitt about. Yeah, no, there's a lot of great ones.
So go down to Pitt.
Thank you. Yeah.
Fascinating talk about lots of things I've thought about separately, and I'm having a lot of trouble getting them together to what my previous ways of thinking and trying to understand your really interesting stuff here. So on the one hand, in my earlier work, I worked a lot about what we called interfield theories, and theory was too strong a term, so I came to call interfield relations. And it was like part-whole relations, like genes are parts of chromosomes, or structure-function relations, or some field finds something and another field finds its chemical nature or something like that. So I've thought a lot about those kinds of interfield relations. And in your idea of constraints, if genes are parts of chromosomes and we've got biparental inheritance, then we don't get a whole set from our mother and a whole set from our father that stay together. They've got to get mixed up. That actually happened historically. So putting the two things together ended up making changes for both of the views reciprocally. So it's a reciprocal interaction. And I guess that's all fitting with your idea completely. All right, now, I've thought quite separately about what I call strategies for construction, evaluation, and revision. You took, as philosophers of science in the 20th century almost always do, just the evaluation strategies to look at, truth conditions and predictiveness and et cetera. And now you're trying to bring those in, so as influencing interfield relations. And I had never quite put those two together in the way that you're doing it. So you said,
so let me see if I can put these together. So I think what I want to say, in trying to translate into this, is that I would want to argue that the interfield relations provide constraints on evaluative, on how the evaluations would proceed, right? So if this is right, that genes are a part of chromosomes, then we should expect the following sorts of evaluative outcomes. And that those expectations, those biases, and I realize I'm using subjective language, which is making me uncomfortable here, but that those provide guides to how discovery proceeds. Right? So yes, I focused on evaluation, but that's because I think, at least what I was focusing on here, is that the way a lot of times discovery proceeds is we have a target in mind. We say, here's what would count as success, is something that can predict this level of accuracy, or that I can use, knowledge that I can use to manipulate and control the progression of this disease. Right? And so then we have that evaluative standard in mind, and then our discovery is aimed at that. Right? Now what I haven't done is talked about how constraints influence also the trajectory. I've only talked about them influencing the goal. Right? And what I don't know, and this is truly, I just haven't worked this out in enough detail to know if I can make this, I'm going to make a conjecture, which is that as you think about sub-goals, right, you've got a big goal, discovery is, at least very often, I suppose here I'm showing my CMU roots of sort of Simon and Newell ideas, is often about establishing sub-goals that you're trying to meet along the way. And so I don't know whether the constraints influence which sub-goals you might pick out. My guess is yes, but there it's probably not going to be purely on evaluative dimensions. So I think you're pointing towards some really interesting open questions, which is, the idea of applying these to discovery, that was the sort of newer stuff that I was trying out here, and I think this is, you're really pointing to a sort of color and complexity to it that I hadn't engaged with yet.
okay. I think there's more to talk about, but not right now.
Okay.
I think we have time for one more question. Are there any questions? So let me ask my question.
Yes.
Just a minor question. You said that the constraints between theories exist independently of our discovery or such constraints. So you think that this is quite a logical relation between the theories, in the sense that they can be both false, but the constraints exist for some logical relationship between these two theories, or do you think that these constraints exist independently of us because of these two theories? If they are true, they represent the world, so there's a kind of mirroring the real structure of reality. So we have to discover the constraint between two theories in the same sense in which we discover the constraint in the natural, physical.
That's right. I would not personally use the word logical, but it's much more the first. Because I think of constraints as, at their core, basically conditionals. To say S constrains T is to say, if something changes about S, say in the case of the truth constraint, the belief, then this constrains what I do about T, right? So it's very much about this idea of figuring out how things relate to one another, but the things need not be what's actually in the world, right? So I can show that, this insane theory, if it were true, would constrain this other one to have this form, say. Now we know that this one is not how the world actually works, but that constraint I still want to say exists. Just like I can have a completely, if I've got a set of axioms in a logical system, I can prove theorems relative to those axioms, even if I think that there's no system in the world that those axioms are good, for which those are a good description. Right? So it's much more the sort of constraints as conditionals.
So, thank you.
Thank you.
Is there a break?
A break, yes. 20 minutes of break.
So 20 minutes.
We're going to have breakfast at the MoMA because the bar is. We are going to the MoMA because
Okay, so the first time presenting some of the stuff. The first half I presented before, the stuff